Hi. In the previous lecture we talked about perspectives, how we represent problems. In this lecture we're going to talk about heuristics, how you go about finding solutions to problems once you've represented them in your perspective. So what a heuristic is it's just a technique, it's a tool, it's a way in which you look for new solutions. So in a sense we've already talked about this, right? When we talked about those landscapes, what we're really talking about is hill climbing on those landscapes. So I sort of assumed you're at some point and what you do is climb hills. So when I define things like a local optima, right, so here's a picture of those local optima, what I was implicitly assuming is that if I'm at some point here, that I can climb a hill and get to here. So the reason these are local optima is because if I tried to climb hills, I'd be stuck at any one of those points because any direction would be down. But hill climbing, this idea of just sort of climbing up a hill, is just one of many possible heuristics you could use. Now heuristics are going to be defined relative to the problem you're trying to solve. So for example, one famous heuristic that's in a lot of books on how to innovate is called do the opposite. What does do the opposite mean? It means think of what the existing solution is and do the exact opposite. So for example, think about how it is that when you go buy something, somebody else tells you the price. What would the opposite be? Do the opposite would be that you actually tell them the price. Well, a lot of companies have been started that do exactly this. So a company like Priceline, you go to the hotels and you say to the airlines, here's how much I'd like to pay to stay at your hotel or to use your airlines. It's the exact opposite. Or alternatively, you can think about firms producing products. We normally think that they want to be lower cost. They want their cost below that of the other firm. Well, you could do the opposite and say, I want my price to be higher because I want to signal quality. So doing the opposite is a strategy that sometimes leads to really interesting innovations. That's a heuristic. Now you can think of this in the context of problem solving generally by there's some sort of solution that exists. I'm going to do the exact opposite. So if everybody else makes grilled cheese sandwiches by putting the cheese between the bread, I'm going to do the opposite and I'm going to actually put the cheese outside the bread. Now if you haven't tried that, it's actually pretty good. Here's another one. Big rocks first. Now, Stephen Covey has written a bunch of books on what makes people successful. What rules do you follow to be successful? When you think of these books, like the 7 Signs of Successful People, or almost any one of these self-help books, they're filled with heuristics. And one of those heuristics often is big rocks first. What is big rocks first? It says, suppose that you have the following task. You've got a bucket here, and you've got a bunch of rocks that you've got to put in that bucket of various sizes. Put the little rocks in first. What happens is that the bucket fills up the little rocks, and then when you put the big rocks in, they don't all fit. They spill out the side. But if you put the big rocks in first, right? So let's erase all these rocks, and let's start over. To redraw our bucket. If I put the big rocks in first, then when I put the little ones in, they'll fill in the gaps here, and everything will work fine. So big rocks first, little rocks second, if you're filling a bucket. And Covey argues that this is something that successful people know how to do. They put the big rocks in first. Now rocks here, right? It's not like most successful people spend a lot of time filling buckets with rocks. The idea here is big rocks represent the important things. So Covey's saying if you want to be successful, deal with important things first. That's the sign of that's a rule, that's a heuristic that successful people use. So what he's saying is there's a lot of problems out there where if you follow this heuristic, you'll find better solutions if you deal with big rocks first. Here's the rub, though. There's a famous theorem in computer science called the no free lunch theorem, proved by Wolpert and McCready. And in this theorem, what they show is the following. If you take 2 heuristics that each tell you to search the same number of solutions, so by that I mean if you had do the opposite versus random search, or do the opposite versus check the thing that's one bigger in your representation. So if they each tell you to search the same number of points, then if you look across all possible problems, now again, all possible problems is going to mean that some of these problems are incredibly hard and some are really easy. That no heuristic is any better than any other. So if you take a heuristic like big rocks first, that means that it's no better than any other heuristic across all problems. So does that mean that Covey's wrong? No, it doesn't mean that Covey's wrong. Because the no free lunch theorem says, again, if you look, and here they use the word algorithm instead of heuristics, but if you look across all problems, no heuristic is better than the other. What Covey's saying is he spent a lot of time in management, and what he thinks is the types of problems you see in management lend themselves to the big rocks search first heuristic. The types of problems you face as a person are big rocks first kind of problems. And so therefore, big rocks first is a good algorithm to use, a good heuristic to use to find solutions to problems. Here's another way to think about the no free lunch theorem. If you don't know anything about the problem, if you don't know something about the type of the problem, then no heuristic is really that much better than any other one. Or if you don't know if your perspective on the problem is very useful, you might as well just hill climb. Once, though, you've learned something about the problem, you might realize that, this is a big rocks first kind of problem. But it could be the case that it's not a big rocks first kind of problem. So, for example, there's some things that are little rocks first problems. Let me give an example from my own life. I put in a fence around my yard and I had to dig a whole bunch of holes. So if you're digging a hole in the ground like this, right, so here's the hole you're going to dig, and there's big rocks in here and little rocks in here, you actually want to take the little rocks out first, because if you don't take the little rocks out first, you can't get the big rocks out. So if you're filling a bucket, it's big rock first. If you're digging a hole, it's little rocks first. So if you don't know anything about the problem, what the no free lunch theorem says is no heuristic is better than any other. If you know a lot about the problem, you can figure out, should I do big rocks or should I do little rocks? Now, we're talking a lot in terms of metaphor. Let's actually take this to real problems, and let's see how these heuristics, in particular having diverse heuristics, is really useful in terms of finding solutions to problems. So let's suppose I've got a representation of a problem that consists of 2 dimensions. So I've laid out all my possible solutions in this big grid. And these could be, anything you want. So these could be, let's say, these are pints of ice cream, and on this side, on this axis, I've got the number of chunks, right, chocolate chips in it, and this is, let's say, the size of those chocolate chips. This is my representation of that problem. Now, what I could do is I could think, what's my heuristic? Well, my heuristic might be that I look to the north, south, east, and west. So that's one heuristic. And these are actually formally known as the von Neumann neighborhoods. And that'd be one way that I could look for possible solutions. But that's not the only way. I could take these same pints of ice cream, and you could have somebody else who says, well, that's sort of inside the box thinking. I'm going to look to the northeast, northwest, southeast, and southwest. And this is a different way, different heuristic, a different way to look for solutions. If I have one person who looks like this, and another person who looks like that, and I combine them, right? What do I get? I get that I look at more points. So diverse heuristics are really useful if we have different ways of searching the space of possibilities because of the fact that we're actually going to search more points. So let's combine all this for a second. What were perspectives? Perspectives were ways of representing the problem, right? So one person might have a perspective that looks like this, another person might have a perspective that makes those same, problems, where the same set of solutions look like that. What is a heuristic? A heuristic is how we search. So one person might hill climb, and so that person would get stuck at these points, right, and these 2 landscapes. Another person might not hill climb. They might sort of have do the opposite rule, which means that they sort of jump all the way to the opposite side of the space. Well, that may mean that they don't get stuck at this point because they jump all the way to here, and it might mean that they don't get stuck at this point because they jump all the way to there. So what we're going to see in the next lecture is how diverse perspectives plus diverse heuristics enable teams of people, groups of people, to find better solutions to problems. So let's wrap this up. Previous lecture we talked about perspectives, and how perspectives are representations of problems. In this lecture we talked about heuristics, which is how we search within our perspectives. And we learned this important theorem called the no free lunch theorem, that unless we know something about the problem, no heuristic is better than any other. But if we do know something about the problem, then we might be able to come up with a better heuristic. We've also seen how diverse heuristics, if given a problem, if I look in different directions than you look, that means we search for more points. What we're going to see next is how if we've got lots of people working on a problem, and we have lots of different perspectives and lots of different heuristics, then collectively we're going to be able to do better than any one of us could do individually. Okay, thanks.